Welcome to this webinar on the Consumer Dashboard. The Consumer Dashboard has been conceived as an extended version of the data processing workflow plugin, based on emerging needs identified during the project. It has been developed by ICT Abovo as part of the UPCAST project. Its implementation has been based on the GoodFlows research prototype. The Consumer Dashboard groups together three essential UPCAST components. First, the data processing workflow plugin, devised for the design, verification, re-engineering, and management of data processing workflows. Second, the consumer-side privacy and usage control plugin, allowing for the specification of comprehensive access and usage rules and reasoning thereof, as well as conflict identification and resolution. And third, services for unified access to several UPCAST plugins, thereby offering data consumers with a unique point of interaction with UPCAST functionality. In the following, we'll first provide a brief description of the Consumer Dashboard, focusing on its main features. Then we'll explain why this tool is particularly relevant for SMEs, especially those with limited resources. Next, we'll look at a concrete case study from the UPCAST pilots, followed by a live demo of the system, to see how it works in practice. We'll finally wrap up with the key takeaways. So, let's have a look at the main features of the Consumer Dashboard, starting from the semantic modeling capabilities. The dashboard represents organizational aspects, such as data types, roles, purposes of processing, operations, events, and context types, as semantic graphs with well-defined hierarchies and relations. A key UPCAST achievement is the ability to import and semantically align these models with external ontologies, such as DPV and ODL, or domain ontologies, through a dedicated mechanism which ensures interoperability with existing standards. On top of this semantic foundation, the Consumer Dashboard offers both a policy administration point and a policy decision point. The PAP is used to specify and manage internal policies, regulatory obligations, and organizational rules, whereas the PDP reasons upon them, along with data providers' constraints, in order to evaluate workflows and access or usage requests. This doesn't result just in yes or no answers. It also helps detect policy conflicts and inconsistencies, highlight where a workflow violates a rule, and guide re-engineering towards compliant alternatives. The dashboard offers a visual environment for modeling data processing workflows. Users can design workflows graphically, manage the datasets involved, and configure all relevant parameters for tasks and edges, such as actors, operations, assets, and constraints, as well as properties at the workflow level. This makes complex workflows more accessible to non-experts. A fundamental feature is the ability to verify and, when needed, re-engineer workflows against both internal and third-party rules. The system checks whether a workflow complies with organizational policies and external usage constraints, identifies semantic conflicts, and supports their resolution. It also includes functionality to negotiate the processing and use of datasets in the context of a workflow, aligning consumer intentions with provider conditions. Once a workflow model is validated, the dashboard can translate it into an executable Nextflow script, mapping the operational logic of the workflow model to Nextflow and injecting UPCAST-specific commands, mainly for execution monitoring. This closes the gap between high-level specification and actual execution. Finally, the Consumer Dashboard acts as the main interface to several UPCAST plugins, such as negotiation, resource discovery, and environmental impact plugins. This gives data consumers a unique, coherent point of interaction with the entire UPCAST ecosystem. Now that we've seen the main features of the Consumer Dashboard, let's look at why these capabilities are particularly important for SMEs, especially those operating with limited resources. Indeed, SMEs often don't have dedicated legal or compliance teams, yet they still need to deal with GDPR, DGA, and complex provider contracts. The Consumer Dashboard automates checks of regulatory, corporate, and provider-specific constraints directly on the data processing workflows. It can detect conflicts and support their resolution early, reducing both overheads and the risk of noncompliance. At the same time, SMEs want to innovate with data from marketplaces and partners. The dashboard allows them to combine these datasets with their own, while checking alignment with internal policies, regulatory requirements, and third-party constraints. Automated checks spot conflicts early and guide users towards compliant options, so they can innovate without taking uncontrolled legal or contractual risks. Finally, all this functionality is available through a single, easy-to-use interface. From the same place, SMEs can design workflows, discover datasets, negotiate with providers, generate executable workflows, and access value-adding services such as environmental impact estimation. This puts capabilities that would normally require multiple specialized tools and teams within reach of small organizations. Now let's move to a case study, referring to one of the UPCAST pilots, notably that of the Major Development Agency Thessaloniki, an organization for the local development of several municipalities around Thessaloniki. In this pilot scenario, The relationship between atmospheric pollution and the resident population is investigated, aiming at evaluating per capita environmental exposure and identify areas of high pollution burden. In this context, the data processing workflow of the figure is designed. It makes use of two datasets. First, an environmental dataset containing air quality measurements from the municipal network of Thessaloniki, and that is the holder of this dataset. Second, a demographics dataset that needs to be acquired from the respective data holder. In the demo that follows, we'll see all steps of workflow design, data discovery, negotiation with a data provider, environmental impact estimation of the workflow, and generation of executable workflow. Most important, we'll see how that internal policies and constraints defined for the dataset by its provider impact the workflow blueprint, resulting to its automatic verification and re-engineering for adhering to these policies and constraints. The final, compliant workflow is depicted in the figure. Let's now watch the demo.
We begin by logging into the consumer dashboard as an MDAT user. The dashboard offers 5 main menus: Information Model Editor, Policy Administration, Process Modeler, Process Negotiations, and Datasets. Since both organizational policies and data processing workflows rely on the organization's information model, we start with the Information Model Editor, a domain-specific ontology capturing MDAT-specific data types, purposes, operations, roles, and rules has already been imported. It is based on the data privacy vocabulary and the ODRL vocabulary, with MDAT-specific entities placed under higher-level DPV and ODRL concepts via IS-A relations. The graph area allows visual editing of information classes and hierarchy structures, organized in separate tabs for different ontology graphs. The list displays entities alphabetically for quicker navigation. The properties area shows attributes, relations, and applicable rules for any selected entity. For example, the data type demographic data inherits from the more general ENA data type, non-personal data and statistical confidential data, and is more general than population count. Similarly, in the roles graph, the role MDAT researcher specializes the DPV concept human subject. In the operations graph, MDAT operations like calculate urban green indicators and compute pollutant per capita ratio specialize the DPV operation derive. These hierarchies enable rule propagation. For instance, defining a permission for the operation derive automatically applies it to all more specific operations such as compute pollutant per capita ratios. With the information model in place, we continue in the policy administration menu. This interface allows users to create, edit, delete, list, and search rules, and to extract meta rules by propagating defined rules through the ontology. A rule consists of 5 components: general information, that is type of rule, description, and purpose; action definition, that is the actor, operation, and resource along with the corresponding constraints; pre-actions, for defining one or more logically related required actions that must or must not have preceded the enforcement of the rule; post-actions, for defining one or more logically related required actions that must or must not follow the enforcement of the rule; and contextual conditions under which the rule applies. All concepts are taken from the information model and selected via pop-ups or auto-completion. As an example, we define a permission allowing researchers, for the purpose of non-commercial research, to perform the operation assess compliance with EU limits on pollution per capita report, with the post condition to store the result. Defined rules appear in a list where they can be viewed, edited, or deleted. The system is deny-biased, meaning that actions are only permitted when at least one explicit permission applies. To improve performance during real-time requests, the system can proactively extract meta rules from the explicitly defined ones. By clicking Extract Meta Rules, rules are propagated down the hierarchy. For example, a permission to store derived data will automatically apply to specific data types such as pollution per capita report. Next, we move to the Process Modeler, the interface for creating data processing workflow models. The central design area is used to graphically construct workflows by combining tasks and edges describing the control or data flow between tasks. On the left, the user sees the list of processing operations defined in the information model. The workflow can be associated with intended purposes and with the roles permitted to initiate it. Users can import datasets they already possess by dragging and dropping or search connected marketplaces via the Resource Discovery plugin. Right-click and select Add Dataset, inserts a node. When adding a dataset, the user can search by type, name, marketplace, or free text. In our example, a discovered third-party dataset includes an ODRL policy permitting transform and derive for non-commercial research, prohibiting share, and obliging the dataset to be deleted after derive. Before including an external dataset in a workflow, the user must annotate it with the appropriate data type from the information model. Selecting a discovered dataset automatically initiates a negotiation with the datasets provider. The Process Negotiations tab displays its status, involved parties, negotiation history, in terms of exchanged offers and requests, draft of the natural language contract and resource details. Negotiations may be terminated at any time. Back to the design area, datasets are associated to tasks using edges, the same mechanism that connects tasks. Edges are characterize the type of data carried, the flow type, and optional conditions. Each task may contain one or more execution profiles, which describe how that task may be performed. A profile defines the actor, the asset, the operation, and any constraints. This allows alternative actor-operation-asset combinations for the same task. The execution profile for the clean and normalized task of our example defines as actor any individual holding the role researcher, while the asset upon which the task will be performed is the discovered dataset. More than one actors and assets can be jointly defined in the same execution profile, as is the case with clean and normalized task that processes two datasets. Finally, conditions may need to be added in order to further restrict the execution of a task, whereas constraints can also be defined for the actor operation and asset elements of the profile. Now, we'll show how compliance with both internal organizational policies and third-party dataset constraints is achieved. For this, we open the fully defined that workflow of our case study, designed to evaluate per capita environmental exposure in Thessaloniki. It uses an existing environmental dataset and a demographic dataset, the latter being under negotiation with the data provider. First, the workflow is verified against internal organizational policies. By selecting Verify Process Model, the system displays the compliant version alongside the original, thereby allowing comparison between the original and the compliant workflow. In our case, a new store task is added because of the permission for researchers to perform assess compliance with EU limits requires a post-action to store the resulting data. After adopting the verified workflow, it is next checked against third-party dataset policies. Here, two conflicts relate to the demographic dataset under acquisition. The first conflict concerns the share task, and there is no alternative for its resolution. The second conflict concerns the compute pollutant per capita ratios task, and the system has a recommendation for resolving the conflict. We can apply the recommendation, or make a request for modified access and usage rights according to the workflow intentions, by pressing the Negotiate button. In the latter case, we may change any parameters related to its processing intentions or the provider's offer, such as the suggested price, prior to submitting the new request. In our case, we opt for investigating the conflict resolution recommendation. We see that the recommendation concerns the addition of a delete operation as a post-action to the compute pollutant per capita ratios task. Checking the dataset again, we notice that this is because the conflict has emerged due to the provider's constraint that the dataset should be deleted following the execution of a derived task. Since the compute pollutant per capita ratios operation constitutes semantically a specialization of the derive operation, it is also subject to this constraint, thereby creating the conflict on the associated task. We apply the recommendation. As a result, a delete task is added to the workflow immediately after the compute pollutant per capita ratios task, so that the dataset will be asynchronously deleted while processing continues. The system then performs a new round of workflow verification. One conflict remains. This is caused by the presence of a share task, which is explicitly forbidden by the dataset's ODRL policy. Therefore, we delete the task and all associated edges are also automatically removed. We search for conflicts again, no conflicts remain, so the button has turned green. With no remaining conflicts, we proceed to negotiation. In this case, we may accept the provider's offer, as the data processing workflow is now compliant with the provider's policy, or decide to create a new request in order to suggest some modification. Here, we accept the offer, and the negotiation status updates accordingly. The consumer dashboard also integrates with the plugin for environmental impact estimation. By navigating to the corresponding tab, we can estimate the energy required for executing our workflow. To this end, we map semantic operations to environmental categories such as data processing or insights extraction, and define properties of the execution environment, such as whether it is Dockerized, as well as features of the processing units. These include the number of cores, the memory, the processor speed, etc. Next, we press the Estimate Energy button, and the consumer dashboard displays the results calculated by the UPCAST environmental plugin. Beyond design and verification, workflows can be exported into executable Nextflow scripts. Using the Export Nextflow script option, The system generates a complete Nextflow workflow with UPCAST-specific extensions, including notifications for real-time monitoring. Execution details, such as the command invoking a Python application, are taken from constraints defined in each task's execution profile. In the generated script, we can see the definition of the overall workflow and the executable specification of tasks such as generate graphs and visual summaries, with input, output parameters and the script to be run. Finally, the negotiations and acquired datasets views allow users to access negotiation histories and dataset details independently of any specific workflow. Using the Process Negotiations view, we see the list of negotiations, with their ID, status, last update time and corresponding workflow. While selecting a negotiation, we can see its full details. Similarly, selecting the Datasets view, we see the list of acquired datasets, including their names, IDs, and semantic types.
To wrap up, here are the main points to remember about the consumer dashboard. First, it is built on a strong semantic foundation, modeling organizational concepts as semantic graphs aligned with domain-specific and standard ontologies such as DPV and ODIL. This standards-based approach means that policies and workflows are structured, interoperable models that can be queried, validated, and reused across tools and organizations. Second, the dashboard includes both a policy administration and a policy decision point. The former allows organizations to specify and manage their internal policies and regulatory obligations. The PDP evaluates concrete requests and workflows against those policies, as well as third-party constraints, thereby moving from policy documents to automated decisions and compliant by design data processing operations. Third, the consumer dashboard covers the whole lifecycle of a data processing workflow. Users can visually design and manage workflows and datasets, verify and re-engineer them against internal and third-party rules, and then translate the validated models into executable Nextflow scripts with UPCAST-specific monitoring commands. This closes the loop from high-level processing intentions to real, monitorable execution. Finally, the dashboard acts as the main entry point to the UPCAST ecosystem, allowing data consumers to reach its offerings from a single, usage-friendly interface. This unified access is crucial. It means that compliance checking, dataset discovery, negotiation, and sustainability analysis are not scattered across tools but are available in one coherent environment. For further information, please contact ICT Abovo. Thank you for joining our webinar.